Welcome back. In the previous section, we saw about selection biases that can occur in cohort studies. So by now we have understood what selection bias is. We've seen examples of how it can occur in case control studies, the names of certain biases, and we also saw how selection bias can happen in cohort studies. In this particular subsection, we are going to see how to handle selection bias in observational study designs. We are very familiar with how to handle confounding, and I'm sure you listened to it in previous lectures. So confounding is usually handled at the design stage or at the analysis stage by methods such as restriction, matching, regression, stratification. So these are methods that can, help your study steer clear of confounding. Let us quickly take a look at how selection bias can be handled. And it is not very straightforward and not always possible to handle a selection bias once it has occurred in your study. Sometimes all that you will be able to do is just report the selection bias that has occurred so that the reader will be able to interpret your results with that sense of caution. So in the design stage, you can be very careful with the selection criteria, with the place from where you will be recruiting your cases or controls in a case control study, or the type of people you will be including in your study. We need to be very careful that the selected people are not very different from the eligible people. There should be no systematic differences between the selected cohort and the eligible cohort. That said and done, there is only so much you can do at the stage of study design because of operational reasons, because of feasibility, because of funds. There are some compromises that we do at the level of selection for all these reasons. So if such measures have led to selection bias in your study, then we will quickly look at a couple of ways we can handle them. The first one that we will be looking at is stratification. And this is not something that is very new to you. We have understood stratification from confounding, which means there is a certain variable based on which you will stratify so that inferences of causality are made within specific strata of that particular variable. Now, if you take this example, let us say E is treatment for HIV and D is AIDS and U is level of immunosuppression and L is the symptoms and C is, say, follow-up or loss to follow-up. So when you have this type of a DAG where, there is conditioning on C, which has happened because of the study that you've done. C could be self-selection, C could be loss to follow-up, C could be missing data. So when you are conditioning on this factor, we have understood that it opens up a pathway ELUD. So one thing that you can do to ensure that this pathway does not remain open is to stratify on the variable L. Now, what happens when you stratify on L? It closes this pathway that you had opened up by conditioning on C. So I'll repeat again. So there is this factor C on which you had conditioned and thereby inadvertently opened up a pathway between E and D. And to close that pathway and to correct this, you are going to stratify on L so that you are able to close this pathway. And by stratifying, we mean the inferences of causality between E and D will only be made within specific strata of L. So this is one way of handling selection bias that you have introduced into your study. But does stratification help always? The answer is no. Now let us take a look at this DAG. So there is this exposure which leads to disease and you have conditioned on a certain variable C. You also know that there is this unmeasured variable U which is related to disease and the unmeasured variable through a measured variable L is also associated with E. So exposure is related to this value L and there is this unmeasured variable which is associated with both L and with D. If you remember our previous example of treatment for HIV and AIDS, U was this level of immunosuppression which led to symptoms represented by L and also led to disease which is represented by D. The exposure was treatment to HIV treatment which is also leading to L, which can also have some side effects and lead to symptoms. Now in this case, C is not a collider and you have conditioned on C by selecting people into your study, but L is the collider here. So you cannot repeat what we did in the previous instance. You cannot condition on L here. What will happen if you condition on L? Now, because L is a collider in this case, by conditioning on L, by stratification or by matching or any such measure, you will be opening up a pathway E, U and D. So this is an inadvertent side effect of conditioning on a collider L. So not always does stratification help, because the moment you stratify on a variable or you match on this variable, or you're trying to control for this variable L, you are going to open up this pathway, and that will affect your causal inference. So what then is a solution when you have a DAG like this? You cannot stratify or match based on this L variable. Now a possible solution in this case is what we call inverse probability weighting. So in inverse probability weighting, each individual, each participant in your study is assigned a probability of remaining under follow-up, probability of remaining uncensored. And this probability, like you see, is dependent on the exposure and all other possible covariates. So using the information on exposure and all covariates that we have for all people in your study, we will be calculating a probability of remaining under follow-up for each of the people in your study. Let us say this probability is 50% for a given person. The inverse of this will be the weight you assign to that participant in your study. Now 1 by 0.5 is 2. So this particular person in your study whose probability of being in your study is only 50% will be counted as 2. That is the weight we assign for this person. Now why do we do this? Because we do not want to be only left with the selected subset of people who remained in your follow-up. We also want to account for those people who did not stay in your follow-up, and this we do by assigning weights, and these weights are calculated as an inverse of the probability of somebody remaining under follow-up. Now inverse probability weighting does not mess with the collider. It does not, it eliminates all the backdoor paths that lead to C. So in that case, in cases where you are not able to control for a third factor by stratification or by other methods, because your DAG informs that if you do that, you are going to open up more pathways, and that is not a very uncommon instance. Many a time when we try to adjust for confounding by conditioning on certain variables or maybe match or stratify, we inadvertently introduce more bias into our study than initially was. So in these cases, inverse probability weighting may be a better method to choose to control for selection bias. So why then don't we do inverse probability weighting all the time? Because there are two very stringent requirements for inverse probability weighting. One is a thorough knowledge of the DAG for your causal inference. You need to know the exact details on all the variables that have participated in your DAG. You need to know all the pathways so that you are aware of which ones you shouldn't mess with, which ones you should be taking into account, which colliders you should leave alone, which backdoor pathways you have to close. So a thoroughly thought out and drawn DAG is a must before you enter into inverse probability weighting. The other requirement is data on all these covariates. So we just saw that this probability is dependent not only on the exposure but also on all the covariates which led to them staying back in our study. For example, in the HIV/AIDS example, we saw that somebody's level of immunosuppression, somebody's experiencing of symptoms is all deciding whether or not they will be in our study. So do we have data on this? Have we collected data on these covariates in our study? Are these covariates even measured? So only when these are measured and only when your DAGs are very clearly drawn out will you be able to employ inverse probability weighting to control for selection bias in your study. So to sum up this section, we have seen two major methods which we can use to handle selection bias that has occurred in your observational studies. We have seen that stratification cannot always help, and we have seen that inverse probability weighting can help in these cases where other methods don't work. But to do inverse probability weighting, you will be requiring a very thoroughly drawn DAG and data collected on all the covariates that are going to influence the probability of somebody being retained in your study or the probability of someone selecting themselves into your study. You need data, all these covariates. Finally, beware of inadvertently introducing more bias into your study than there initially was. It is possible that by overzealously controlling for certain factors and conditioning on certain factors, we may inadvertently be introducing more bias into our study, and we need to steer clear of it. A quick word about randomized experiments. So in the initial section, we had a question on whether randomized experiments can also suffer from selection biases. Well, yes, we think that randomization does away with all biases that can happen when people are included into your study. And yes, for the most part of it, it is a great weapon to eliminate confounding and some forms of selection biases that can creep into your study because of your selection criteria. Because in randomization, there's no criteria, you're just randomizing people to receive or not receive the treatment. So that part is taken care of by randomization. But what happens after that, say if people are lost to follow-up or there is missing data in your study, now that is something that randomization does not take care of. So even if you were doing a randomized experiment, we recommend that you look out for biases that can creep in due to loss to follow-up or due to missing data and handle them using appropriate methods. Thank you very much.